Tita Ferrara. As you can see from the screen, I hope you can hear me. Please, can you give my... Okay, great. Thank you so much. So welcome to the first session of the FluxMotor Introduction training. This is a new training that we planned for this year. And we hope that this training can help you to better understand the FluxMotor functionalities and to use it in a better way as possible. So let me put my reference, my mail in the chat in case you have some doubts after the training, after the session. Okay, for any other problems or doubts or questions, please don't hesitate to open a new support request using our site, because me and the colleagues of mine will reply you, will help you in your stuff. Okay. So second thing, I put the link of the material in chat for the training. You will find a link with the material for today. Day by day, I will share with you at the beginning of the session the material of the day. For the moment, you will find just PDF documents that I shared with you during the session, and the instruction for the exercise. So you can use it to reproduce the example, or just follow the steps that I will do during the session to complete the exercise. So for any question, don't hesitate to put some some message in chat. I will try to reply at all the questions. If I'm not able to do it, I will take the notes and I will reply after the session. Okay, so we can start. And let me just take the presentation. Okay. So okay, overview and prerequisites for the training. Not sure if all of you already know FluxMotor, but just to introduce the tool is dedicated and addressing to the global design of electric motors, is a tool specific for electric motor. So it enables engineers to accelerate the design of machine, quickly explore a variety of configuration while considering multi-physics constraints. This is the plus of FluxMotor. Through this course, the participant will be introduced to the FluxMotor interface, function, and workflow through a simple example. We will see an example, a multi-physics example of APM motor for automotive application. And we will see also how to export the model for the other Altairs tool. And also, as well as the optimization process with hyperstudy will be shown. So it's a quite complete course where you can see all the function we have in FluxMotor. And let's see the learning path. So we have two different learning paths. One is starting with Flux Introduction, because we have different tools in electromagnetics dedicated to e-motors. The difference here is that Flux is a general finite element tool, so we can use it for to design electric motors, but not only. And we have FluxMotor, and we have also two trains dedicated to FluxMotor, other two two trainings that are more based on theory and a specific type of motor. We have one dedicated to BLDC motor and another one dedicated to synchronous reluctance motor. Well, since FluxMotor, as we will see, is able to export the model ready to solve for flux, we normally suggest also to attend the flux analysis of electric motor training. To finish with the last one that you can see, that is at the right of the screen, that is the SimLab multiphysics analysis of electric motors. And this training is a pure finite element training carried out with SimLab. And SimLab is another Altair tool that includes the Flux solvers. So the interface is completely different from Flux, but it contains the Flux solver and the CFD solver, the mechanical solver. So it's very powerful to carry out multiphysics analysis. So you can work in the same environment and create the mesh in a very powerful way of your model, and solve a couple application or just more physics in cascade. So yeah, for today we will see just the FluxMotor introduction, but don't hesitate to click on this link to see all the other training that we offer. Okay, so the structure of this training is a 3 session of 2 hours. So we will take just a moment. Okay, we will take a short break in the middle, more or less. You can see my mail address for feedback. And yeah, let's start with the agenda. So we will have 6 chapters. Today we will see the introduction to FluxMotor, the general operation, and the permanent motor, so the exercise dedicated to the electromagnetic physics. The next 2 days, we will hand the electromagnetic modeling, and we will start with thermal and MVH analysis. We will see how to optimize a motor with FluxMotor and HyperStudy. So I recommend you to install for the next days also HyperStudy. You can find it in on our site, and the license is the same. So don't worry about the license. You can just download and install it to use it. And we will end with the export functions that we have. The export for Flux, the export for PSIM, for example, or the Twin Activates that are tool dedicated to the full system. The export for HyperStudy, and so on. So don't hesitate to give us your feedback going here. Okay, so the introduction is end. So we can take just a moment. So we can take the chapter 4, the chapter 1. In this chapter, we will see just how to, what is FluxMotor, what can do, what are the motors that are available in it, and so on. So we will see some slides, and then the general operation. In the general operation chapter, we will go directly on the tool. So just a few minutes to introduce the tool and the functionalities. So the FluxMotor aim is to, motor designers have different goals and constraints when designing new motors. They need to find normally the best compromise between cost, performance, and weight. So they deal with multi-physics constraints normally, not always, but normally it happens, such as noise, temperature, and first of all, the electromagnetic efficiency. So FluxMotor has the aim to help designers in their tasks, like what you can see here. So lower cost of material manufacturing, manage thermal and noise issues, and maximize the motor efficiency along the duty cycle, such as get high power and torque density and create lightweight and compact solution. So our solution can be divided into three main poles. The concept design or extensive design exploration, that allows us to do rapid design exploration and ranking for feasibility studies during the concept phase. For this phase, FluxMotor is the tool. So then we have the detailed design with advanced solvers and finite element multiphysics analysis. Here we can talk about Flux, we can talk about SimLab, that is the multiphysics finite element tool as first. And we will have other tools like OptiStruct and AccuSolve. All these tools, these solvers are embedded in SimLab. So we can speak about SimLab in general for the detailed design. And then we also have the system modeling to include inverter strategy or global loads to the machine. For this task, we have two tools, Twin Activate and PSIM, that help us they help us to introduce the full case. And we also have some possibilities to introduce process automation with Python mainly, both for Flux and SimLab. And we also have the possibility to couple optimization and exploration with hyperstudy. So Flux is able to export the FMU directly for PSIM and Twin Activate to consider the full device. And is mainly dedicated to the concept design. Let's see why. So as a concept design of electric machine, FluxMotor is an easy input and fast evaluation, is a multi-physics in one tool, so electromagnetic, thermal, and NVH. It allows to generate automatic reports and automatic ready-to-solve flux model, both for 2D, SKU, and 3D environment. In Flux, we have, in fact, three different environments, and it depends on your machine. Normally, the 2D model is enough. It depends on the difference on the ratio between the length of the machine and the diameter. The SKU module helps the user to carry out analysis considering the SKU applying to the stator, to the rotor. It depends. So it allows the user to better know an accurate, let me say, cooking torque and behavior of the machine in a faster way. So the SKU module is a 2.5 domain, in fact. So it contains multiple 2D domain to hand with the 3D model that is the most accurate one. And today is available just for certain type of machine. It's also optimization ready. So we will see how to optimize our machine depending on our goal for sure. I don't want to lose other time on this because we will see in detail later each aspect of FluxMotor. So just a few information in the following slides. So we can define FluxMotor as a dedicated standalone and multi-physics environment to accelerate the design of a motor concept. It gives us a fast evaluation of techno-economic performance because we can also consider a bit the weight of the parts and the price in some way. It has an intuitive interface and workflow, so it's easy to use. So we don't need to have knowledge about finite element modeling, just knowledge about motors for sure. But not only engineers can use this tool. It is fast and accurate. It depends on your needs because we can decide to be very, very fast and lose a bit the accuracy on some analysis. And we can decide to use the accurate mode to be able to carry out very accurate analysis with a lot of accuracy, with more time to solve the model. It contains an effective machine parts management, and the customization of parts is possible. This means that inside FluxMotor, we normally have different catalogs of for the parts, for the rotor, for the stator, internal and external, and all these parts that you can see here in the library are pre-parameterized. So you can just click and choose one part and see and check the parameters that this part contains. And this means that we are able then to change all the parameters that contains. So this is quite powerful. If you have some needs, like in this case, so you need to add some holes for the thermal management, or if you want to have a different geometry, so you can generate your part starting with Flux. We have three macro, sorry, because the last one it's a news. So with the last version 2023. The first part is allow you to create the external sector, so the sector, so the external part, the 4 lines here. I want to remember that to create a part for FluxMotor inside Flux, you can use the sketcher, you can define point by points your parts. But we need to have just one line in the internal part here as arc, and just one line here. For the other 2 lines here, we don't have a specific constraints, so we can have a segment or multiple lines, no problem. Then we have a macro that is able to traduce the part in an Excel file that is the source file for FluxMotor. And we have another macro that is pretty new that allows the user to generate the part, so generate the Excel file that contains, in this case, parameters. So we can convert our sketch from Flux to FluxMotor to generate fixed parts. That means that the part can be modified in terms of let me say dimension, so diameters, okay, internal and external diameters, But we can also have a part that is parametric. So we can change the distance between the magnets, for example, here, the radius of the hole, and the position of the tasks here, and the length of the web, and so on. So all these features allows us to have an efficient project management with FluxMotor, especially the library helps the user, and the catalogs that we will see of the motors helps the user to have a very simple management for the project, for the full project. It is also ready to optimize. We can see here a comparator that is in FluxMotor. So once we solve our motors, we can proceed with a comparator to compare the efficiency, to compare the constants of the machine, to compare the power density, for example, and other characteristics for sure. So it also allows us to have the connection for advanced study. Normally is FluxMotor as the finite element tool embed. Not all the studies are carried out with the finite elements, but you will see the mesh, and you will have the possibility in any case to export the ready to solve model, as I already told. So this is quite useful if we want to perform advanced study like short circuit tests, like more accurate, like if you want to consider more accurate model for the materials, and so on. Okay, so FluxMotor is mainly for radial flux machine design. We will have synchronous machine with permanent magnet, inner and outer rotor. We have induction machine with squirrel cage, also here, inner and outer rotor. Also, the reluctant synchronous machine are available. I shown you at the beginning the training available on this type of machine with inner rotor. We also have the possibility to add skewing to the slots, to magnets and bars. And yeah, for sure, more machines types to come soon. We are working, the R&D team are working on the wound rotor topology. So I think that this year will be available. I don't have specific data, but I'm pretty sure that by the end of the year, also this machine is available. For other specific machine that are mainly dedicated to the 3D environment, like the axial flux machine, we have in Flux, within Flux, a macro that allows you to generate the axial flux machine model that is parametric, just adding some parameter to the macro. So, for example, the dimension, the number of poles, and so on. The same with within SimLab. So, yeah, the macro allows also you to perform some specific analysis, like Cognitorque, like BackMF, like single working point and efficiency map, as well as thermal analysis. So, yeah, don't hesitate to ask on to test it, or to ask if you need more information. Okay, about testing and evaluating electric motors and the electromagnetic performance, the results are automatically illustrated when the analysis is end. We have a predefined test already available. We have just to put some data to perform the test, such as the BackMF and the Cogin torque, the characterization and the maps, and the datasheet test. All these tests allow us to obtain some results and to share with our colleagues, with our boss, and so on. So also the machine performance, the performance mapping, we can obtain efficiency map with FluxMotor, and we can then generate the report in PDF to share the results with all the people interested in the project. And the PDF file can be read from each machine. So we don't need to have multiple licenses just to check the results of our project. We also have the possibility to do the duty cycle to see the machine performance along the use, the normal use that we suppose. As you can see here, some points that are defining the working points along the duty cycle in the efficiency map. So it's a quite powerful thing. About the IMAG, the impact of IMAG on thermal behavior, we can define we have to define not only the electromagnetic part, so as normally in the finite element analysis, the rotor and the stator, the air gap, but also if we have the water jacket, we need to put to define heat in our model. The case, the external case, the bearings, the shaft, the extension, so the end winding, the geometries of the end winding. And we also have the possibility to consider fins, cooling circuit, for sure, external cooling or internal cooling. And we have as test available the temperature chart from a set of losses, the characterization steady state on the working point. We can perform steady state like one iteration HIMAG on thermal, so we can take the losses from just one iteration. Or we can perform also iterative studies on the HIMAG performances that we obtain to reach out the temperature at the end of the transitory. We also have the transient thermal for the working point model analysis or duty cycles. So it's quite powerful. The thermal behavior is considering the equivalent thermal circuit. So the model is defined as a thermal as an equivalent thermal circuit depending on the geometries. And then FluxMotor considers the loads that we compute within FluxMotor. So at the end, the thermal analysis are quite fast due to this technique. For the moment, the equivalent thermal circuit is not available in FluxMotor, so isn't bad. But we are working. The R&D team are working to be able to export and to manually modify the equivalent thermal circuit from FluxMotor. About MVH prediction, we are able to do heat in early electromagnetic and design phase. This is quite powerful because we are able to consider it in an early stage of the project. So for the single working point, the model analysis is available. The radiation efficiency is available. We have then space-time normal flux density in the air gap, space-time axial pressure. These are some of the outputs available, as well as the most important radiated sound power that allow us to quantify the noise that the machine can produce along the usage, along the working section, and we can plot, as you can see, to the bottom right of the screen, the electromagnetic forces on the teeth. We can see the arrows. Other outputs are available, such as the spectrogram, so the radiated sound power spectrogram in speed engine order area, the radiated sound power spectrogram in speed frequency area, and the overall weighted radiated sound power versus speed. So all these outputs are available in Flux. About connection for advanced study, we already talked about the Flux 2D, the FluxQ, the HyperStudy, and the FMU for the system modeling. So as I told, FluxMotor is a standalone software, but it contains the connection for other Altair's tool. Yeah, the model, the exported model is available ready to solve for Flux. The model is full parameterized. Also, the physical properties are embedded and can be modified. We have a powerful coupling with the Altair HyperStudy. You can see here a catalog from FluxMotor that is populated thanks to HyperStudy that carried out an optimization, for example, and save each model in FluxMotor. We can decide to save all these tests or just the most important one, so the final one. We can run DOE and optimization study. The motor optimization can consider the full duty cycle. We can, as you can see here, visualize the results and the runs project storing the motor catalog. To hand with the export data in FMU format files to use by Twin Activate, PSIM, but also other environments, since the FMU is a standard format. So we can use the FMU with other non-Altair tools. By the way, if you use it with Altair's tool, you are sure that it works fine and is completely, built for this reason. So yeah, up to you. So we had the first chapter, the Flux introduction. We can start with the general operation, chapter 2. Let me take, if you have some question on some question, don't hesitate to put them in chat. In the meantime, let me take the chapter 2. Okay. Okay, no question. So along this chapter, we will see how FluxMotor is built. So each section, we will go through each section, each tab to see the function that we have inside, all the settings, and so on. So here a picture that contains the general architecture of FluxMotor is quite complex. I prefer to show you directly the supervisor and to go through it. So let me open FluxMotor. I hope you have FluxMotor on your machine. So you will be able to perform a test with me. Okay. Great. So let me just close the agenda and the introduction now. Okay. Okay, so the aim, each time that you click on the icon available on your laptop, on your machine, the supervisor appears. So this is the supervisor of FluxMotor. And the aim of the supervisor is to group all the needed application to build and manage the motors and the models. We have, in fact, the motor catalog, part library, materials, the script factory, the possibility to change units here. We have also here all the settings available in preferences, resources, and helps. Then we have the possibility to create directly new motors, just clicking on one of these images, or to open the recent motors that we worked on. In general, okay, we can start with the preferences. So we can start with the resources. So the resource allows us to go directly on our website. From here, you can also download HyperStudy. We have for FluxMotor, and FluxMotor is available with Flux with the same installer. And we are at the version 2023, as in my case. If I click here, oh, sorry, Flux appears, the supervisor, the Flux supervisor appears, and you can see the 2023 version. Also from Flux, you can open FluxMotor. Starting from here, you can just click here to open FluxMotor. This is because these two tools are working together, and our customer that are used to use FluxMotor can be found some advantage to have Flux installed, and the contrary. I mean, the same for people that are using Flux. It could be helpful to use FluxMotor. Okay, so on the help, we can check the version, the licensing here, and going on the forum where we have where you can put some question if you have some doubts, general doubts. Otherwise, you can just open a new support request and share your model, or we can have a meeting, no problem. So we are here to help you in your task. On the preferences, we can see some settings, some general settings. The most important one are the multi-session possibilities here. Here we have the possibility to put some paths. Normally the paths are already predefined when you install FluxMotor on your machine. About a looking shortcut, I don't want to spend time, but it's important just to know that there is some possibilities here to manage them, and to hand with the advanced settings. And here, just some words on the user level, the local level. So I normally used to use the beta user level that allows the user to have some more functionalities that are not completely tested probably, but the debug also logger level allows the user to have a more accurate description of the problem that you are encountering. About here, you also have the setting memory allocation, so you can put yes or no, no problem. FluxMotor will manage the memory in this case for you. And also we have the possibility to enable the distribution mode with Flux, but don't worry about the settings on the memory. I mean, we are working with FluxMotor on 2D models that are normally take not a big amount of time to solve, especially because the mesh is a bit simplified. and it's automatically built from FluxMotor in FluxMotor. So we also have the possibility to go to the units to change them. Also here, and I don't want to spend a lot of time. Just check the current unit. You can just open it and check the current unit if you agree with them, or just change in a quick way. Then we have the script factory that allow us to, just a moment. Okay. I'm just checking. Okay. That allows the user to script and to generate in automatic way the model, to do some changing and so on. Then we have the three most important section. So starting with the materials, that is opening here. Just a moment. Okay. So here we have a catalog that already contains some materials that we can just take to use. So we have e-conductor materials such as aluminum, copper. You can just click on one of them to open it and check all the properties. Like this, you can scroll along the steps. We have insulator. We have gas and liquid for the thermal management. We have laminated material for sure. Simple catalog that contains 10 or something like that number of laminated material. You can for sure take one of them. This includes also FECO material. We also have magnets and steel or iron or aluminum bulk material for the shaft, for example, or for other parts. You can take one of these, you can use one of these materials, or you can define your own material in a very simple way. You can go here and create new, for example, or duplicate. You can just, let me go here, click on one material and duplicate it and then save it in the user catalog here. So yeah, it's quite powerful. We have in the laminated material, we have the possibility to match, to define the losses, to match the losses with an Excel file that contains the losses along the frequency and along the magnetic induction measured in the piece, and so on. So you can just try to manage to use it, and if you have some doubts, don't hesitate to, as I told, to create a new forum request or open a support request if you want to take your question more anonymous. I mean, okay, so if you don't want to show your question in the forum. So then we have the part library. I just clicked on it, and here we have the part library. The part library is a quite powerful thing because it allows FluxMotor to consider parametric parts just to start. So you will find these parts available, and you can just click on one of these library and click on the part to check all the parameters we have in it. The libraries are contains different topologies. For example, we have inner magnet here, outer magnet here, and we have different libraries also for the outer magnet. Inner slots outer slot, inner bar, outer bar, and inner variable reluctance. And here we have different rotor parts, as you can see, that can be used with some parameters. For example, here you can see all the parameters that is containing. This means that we are able to change the position, the dimension of each part in a very quick way. Okay, then we have also the user library. Here, as you can see, the user contains all the parts that you have generated from Flux, parametric or not parametric. It depends on your needs. So inner magnet, outer magnet, and so on. So each type of library that are available in the reference library here is also available in the user library. So, okay. We can manage parts, we can manage libraries, we can create a new library here and put new parts or just copy some parts that already exist. Yeah, in my case, I just want to show you a part. Let me take one of them, sorry. So, for example, this is quite simple. I need to use this part. I suppose that I want to use this part. Okay, so you can just click on the part here, and click on edit. By default, FluxMotor asks me a new part name, and the library name that where I want to save this modified part. So in this case, it's just a test, so I will keep the same name of the original part. Okay, and the part factory will appear here, as well as okay, just a moment. And in the part factory, I can check the source, the Excel source of the part. For example, open source file here. So this is the source file that allow us to have the part in FluxMotor. So this is the structure of the source file. Is an Excel file that contains some constraints, so that has some constraints, and that contains all the data of the part, such as expression, so formula to have the parameterized part, and so on. It's an Excel file is quite complex. We have some rules to follow if we want to generate a new part, and we can check this source file just clicking here on each aspect. So we have the details, we have the status. So each source file is tested before take it in FluxMotor, so we can load a new Excel file, and then the FluxMotor will test it to check if all the things are fine to use it in our studies. Then we have structural data and the user parameter. So user parameter is the same parameters that we will find along the design, and we have some predefined values, but also here we have a description. Please pay attention each time that you use a new part, because also some parameters, each part contains some constraints, and we need to respect these constraints. So along the design, FluxMotor will help you to know these constraints, but it's quite powerful because to check it to check them before, because you are able to understand if there is some limitation respect to the design that you want to reach. So just take a look at a single part. And then you can also, for example, open the source file as I did, and do some modification directly on the Excel file to generate a new part. If you need more information on it, you can visit our website here, the help, I mean. The help and the user guide is available on our site, but clicking on it, you're on the question mark, you are able to see the help directly and search for your question. Okay, so the FluxMotor part is built in FluxMotor, as I already told. We can describe just half of the parts, not all the parts. That then FluxMotor can mirror the part in order to have the full part available. We have constraints, scale factor, formulas to have parameters, and then we have the list of the geometrical entities that are inside the part, such as points, line, the coordinate system that the part is using, for example, to orient the magnets, as you can see here. Then faces, regions, because the let me say the structure is the same of flux. So we have point lines, face region. Face region contains the physics of the face. So contains some more information, some additional information, to hand with the magnets that we have here, for example, in orange. Okay, so I think we already seen just a bit it. Before entering the motor catalog, I want to propose just a short break of 3 minutes, if you agree. Yeah, I leave you the time for a coffee and see you later. In the meantime, if you want to put some question in the chat, please feel free to share any doubt. Thank you so much.